Back. So we were discussing probability. One thing to note is that the sum of the probabilities of all simple events in a sample space must be equal 1. Okay, this is an important notion. The sum of all the probabilities of all the simple events must equal 1. We can use this fact to determine the probability that an event will not occur. So, for instance, if you think that the probability is 0.65 that you will win a tennis match, well, what does that mean? The probability is 0.35 that your opponent will win. You understand, this is 65% chances you win means 35% chances your opponent will win. So the complement of an event A is the event that A does not occur. Complement is opposite. You see, complement of A is that not A, or even A does not occur. We use the notation A super C to designate the complement of event A. Here is what is called Venn diagram. Now you have event A here and its complement is everything outside. Notice that the two distinct events A and A complement make up the entire sample space. Therefore, the sum of A complement and A together is 1 because sample space is everything here. In other words, the complement of event A is the event that A does not occur. A complement designates the complement of event A. Moreover, probability of A plus probability of A complement is 1. In other words, probability of the event A does not occur is probability of A complement is 1 minus probability A. Now this is important. Notice, probability of A plus probability of A complement is 1. So what is the probability of A complement? It is 1 minus probability of A. That's all we have done here. The probability that a college student who has not received a flu shot will get the flu is 0.45. So a student who has not received a flu shot, well, could get flu, may not get flu, but the chances of a person who has not received flu shot who will end up getting the flu is 0.45. What is the probability that a college student will not get the flu if the student has not had the flu shot? Well, probability of will get flu is 0.45. So probability of will not get the flu is 100% minus probability will get flu. So that is 1 minus 0.45, which is 0.55. Okay. A complement together is 1. So this guy is 1 minus this and this guy is 1 minus this. Okay, I hope it's clear. Probability related to statistics. We conclude this section with a few comments on the nature of statistics versus probability. Although statistics and probability are closely related fields of mathematics, they are nevertheless separate fields. It can be said that the probability is the medium through which statistical work is done. So probability is the medium through which statistical work is done. In fact, if it were not for probability theory, inferential statistics would not be possible. So in other words, notice probability and statistics are two different branches actually, but they are closely related. Without probability theory, inferential statistics is not possible. Now, put very briefly, probability is the field of study that makes statements about what will occur when samples are drawn from a known population. Statistics is the field of study that describes how samples are to be obtained and how inferences are to be made about unknown populations. Okay. Now, a simple but effective illustration of the difference between these two subjects can be made by considering how we treat the following examples. So, let's look at this a little bit more. Probability is a field of study that makes statements about what will occur when samples are drawn from a known population, whereas statistics is the field of study that describes how samples are to be obtained. So you want to first work at how you would obtain your sample and then how you can infer about unknown populations. Okay, so here is example of probability application. Condition: we know the exact makeup of the entire population. Example: 3 green marbles, 5 red marbles, 4 white marbles in a bag. Draw 6 marbles at random from the bag. What is the probability that none of the marbles is red? This is a textbook case example of probability. So this is as opposed to statistics. Condition is we have only samples from an otherwise unknown population. Draw a random sample of 6 marbles from the unknown population of all marbles in a bag and observe the colors. Based on the sample results, make a conjecture about the colors and numbers of marbles in the entire population of all marbles. So you see, that's a rather particular problem. And here you don't even know how many marbles are there, let alone what their colors. So you're drawing samples and from them inferring about the bag of marbles. Okay, so that completes this particular section, section 5.1. We will start with problems in our next video. Until then, bye.